Today we're talking about Highway Advisor Radio. This is Tech Talk with MH Corbin. So, Highway Advisor Radio, this is where you have an AM system that's broadcasting on the side of the highway, typically along most interstates. It says tune to, and it may be a frequency such as 1610 AM, most commonly used. This provides highway information such as road conditions, construction, weather-related information. It's been used for many, many years by Department of Transportation's construction projects, airports, just to name some of the few things it's been used for. Most recently, it's been used for hurricane evacuations and things like that, tornado warnings. So there's a lot of different things Highway Advisor Radio has been used for over the years. What I'm going to talk about today is how the technology has changed over the last 20 years and give you kind of a behind the scenes look at the equipment, how it works and what it does. So we're going to start off here. We are in our lab where we do a lot of testing of old and new equipment, just to give you an idea. And what we have here running, this is what we call the BlackMax rack. It's a 19-inch rack that's designed to go into a typical traffic cabinet on the side of the highway. And what we're looking at is a power supply, a recorder player, a transmitter module, and in this case, a GPS synchronizer module. And I'll explain what each one of these does. The power supply module simply takes AC power, typically 110 volts, and converts it to 12 volts. Along the back of this unit, there's a back plane that we call it, and all the modules slide into this 19-inch rack and are commonly found power is applied to each unit from that back plane. So this makes it very easy if you have to pull a component out or replace a component. You just simply power it down, loosen the screws, pull the unit out, put a new unit in, and you're ready to go. You can see through here, it's a 96-pin connector. Everything plugs in very easily and cleanly. Even the novice can do this without pretty much any instruction. What you're seeing here, this is the new version of our power supply. It's called the PSM-PRO. It gives you information here, and as it cycles through, I'll go through what it's showing you. This is the charge voltage going to the battery. There's no battery hooked up, so it's no current or anything right now. The backplane voltage is 13.23 volts, and the current is a little over 2.5 amps. So what that's telling you is, with a fully loaded system, a recorder player, a transmitter, and a GPS synchronizer, this system draws about 2.5 amps of power. Because it runs on 12 volts, if you have a battery backup connection hooked right here, it will have a float charge that keeps the battery fully topped off, and if AC power ever goes away, it automatically converts over to DC power and runs on battery. So if you go to a site for troubleshooting and the red light's on, it means it's running on battery power. If the green light's on, like it is now, it's running on AC power. To give you an idea, because I said this is the new power supply, this is the older power supply. It's called the PSM-1, immediately identifiable by the analog meters here on the front. It does the same kind of function. Instead of cycling through in a digital format, it gives you the DC voltage here and the current charge here going to the batteries. But same thing, power off and on here with the switch, battery backup cable hooks here, and it has the fuses built into here, where the newer style Pro, the very same, fuses built in here, battery backup here, on off switch here. One thing I want to talk about is the recorder player. This is called the DR1500. And it is a recorder player that came out when this BlackMax was designed back in 1997. So before 1997, we had modules that were actually physically bolted to a common backplane device. And it made it very hard for a technician to troubleshoot and pull things off and do repairs. So in 97, we came out with this modular design where it's in a rack based and you can pull modules in and out very quickly. I bring this up because in 1997, the technology was all analog phone lines, such as this. And it had what we call an RJ11 plug, which looks just like this. Your standard telephone line that was in your house. All the years that you had a telephone line, if you're from most generation except the current one, you knew what this was. I'm going to show you something here that most people don't recognize anymore. This is a telephone handset. It's got a cord and everything. My kid doesn't know what this is because you don't see these anymore. Everything now is digital on a cell phone. But back in the day, you had a phone line and a phone cord, and this is how the technology was. It was analog based is what they called it, and this is how everything worked back then. From the late 90s to the early 2000s, this is how every highway advisory radio looked. Had a power supply and a recorder player. All the recorders were controlled with a telephone line like this, or an analog cell phone, which still had a connection from the phone to the unit like this. What I want to show you here specifically is we had to make arrangements over the years to accommodate when we went to digital connections. So this is the DR1500 recorder player out of the 19-inch rack, just to give you an idea what it looks like. Okay, and you see the connections here for telephone. So in the early 2000s, we had customers that were switching from analog phone lines, and they actually had a way to do a digital connection with Ethernet. And this is an RJ45. You'll see how it's a little bigger connection here than the RJ11 down here. So we came out with a device called the Digital Communication Controller, or DCC1. And this is what the device looked like. This device physically would plug in right beside the DR1500 here and allow you to upgrade your HAR system to a digital type of connection. So if you had analog, you wanted to go to digital, you'd add this device in, you'd very easily plug in your Ethernet here, and away you go. You could have an IP-based connection to your HAR system, and your HAR system would still remain current. From the early 2000s to the late 2000s, the DCC1 was the system that we would give you if you ordered a new highway advisory radio. You had a DR1500 and the DCC module, and this gave you the choice in the field for analog or digital connections. So you could use one or the other, or both. You could have the digital connection for your normal day-to-day, and if for some reason it failed, your emergency backup could be the analog phone line. This worked very well for many, many years. Back when we arrived with the DCC3, which is this model here, you'll see it looks very, very similar to DCC1. There are some significant changes here. You'll notice there's now 2 Ethernet ports on this, and you'll notice there's no longer an analog phone port. See how that's gone? Around 2013, 2014, we moved from the DCC1 to the DCC3, effectively eliminating all the analog circuit from the DCC unit itself. You could still use analog, you would just simply plug it into the 1500. The 1500 could still be used with the DCC3. You would just simply have your digital connections into the DCC3 and your analog into the 1500. And this was the configuration we used for a few more years up until around 2017, 2018. So up until then, you could still get analog phone lines in the field. You could still get that type of technology. However, right along the time between 2017 and 2018, there was a push in the industry to get away from analog, whether it was cellular or on the LAN, and go to a digital solution. So we came out with what we call the CAM1. This is the latest module. It's called the Communication and Audio Module, and this is what it looks like. You'll see it looks very similar to a DCC3 at first glance. It has the Ethernet connection here. You'll notice there are no analog connections anywhere on it. Now, this device allows you to replace the 1500 and the DCC. So all this configuration goes away, and this replaces it with one nice package. Now, it is not based on any of this old technology. It's completely new, redesigned. I've actually got it open here so you can see what it looks like on the inside. So this is all the new technology. It's now based on like a computer, where before it was based on a very old style analog setup. So just to give you an idea, show you some of the history, where we were, where we came from, how we migrated from analog to analog and digital, and now we're fully digital setup with the CAM1. So the first question we get, what if I'm a customer and I have an analog phone line and I want to go to the CAM1? Well, it's very easy. You can install the CAM1, you can remove the old analog components with the 1500 and the DCC if you have a DCC, and you can simply buy a cellular modem. So you just buy a cell modem and you plug it into here, you have a cell modem with an antenna, you power it up, and away you go. You don't have to run any lines to the site or anything like that. It makes it very simple. MH Corbin sells a cellular modem kit that we can provide you, or you can go out and source one for yourself. There's 4G, 5G, any kind that you want will work with this device. Next, I want to talk about the transmitter module. This is called the DR-TXM4, and this is the latest transmitter module. We've been making this module for over 10 years. It's the module, the go-to module, AM radio. We can make it any frequency you want, 530 to 1700. Some of the features of this, it actually shows you your power when you're transmitting. It has the modulation lights here. There's a limit light. What that means is we have a limiter built in so it doesn't clip your audio. So anytime it starts getting over 100%, this light will actually kick in and actually keep the audio from clipping. Over on the side, you have all these LED lights and all these numbers. What they mean, if you look up here, you have VSWR, which stands for Voltage Standing Wave Ratio. This is how well your antenna is tuned. And we give you a nice little line to follow. So if you follow this line over to the right-hand side, these are the numbers you look for when you're tuning your antenna. So you slide this switch all the way up, and then whatever numbers are showing here are how well your antenna is tuned. So when you're tuning your site, if we haven't already helped you tune the site from the factory, well, maybe when you did a new installation, you actually want to get where the numbers are the lowest. So the lower the number for your tuning, the more efficient your transmitter is and the more effective your range is going to be. So from the factory, we recommend at least 1.5 or lower for the most efficient signal. You can get away with it at 1.8 or lower, but the most efficient signal you're going to have is 1.5 or lower. If you can get it lower than that, great. Sometimes it's hard to do based on where the antenna is located and how good your ground system is, but that's our general rule of thumb. Anything below 1.8 is acceptable. Anything below 1.5 is perfect. From there, you can slide your switch to the middle setting, which is forward, and it reads the numbers here in the middle. And this gives you an idea of the wattage that the unit is actually broadcasting at. We try to set all of them to 10 watts of power. We try to set them here with a dummy load antenna, which is a 50 ohm load that simulates an antenna in the field. However, once you're in the field under real world conditions with an antenna and a long piece of coax and the ground system, this can actually change a little bit, and that changes based on how well the antenna is tuned. So let's say if the antenna is not very efficient and the tuning is not very low, this actually can drop the wattage down. By comparison, if the antenna is tuned very well, this number should actually go up. And then the last line here is reflected, and that goes over here. This is just kind of a benefit for you to see how well the two over here are matched. This doesn't have a lot of bearing on how you're tuning it. This just gives you an idea of how much reflectivity you're seeing and how well the antenna is tuned. The main ones you want to concentrate on are VSWR, how well the antenna is tuned, and your forward power, how much wattage you have. If you're exceeding the wattage by FCC, they recommend 10 watts of power. You can actually go in here and turn the transmitter wattage down. And to do that, you slide the unit out of your 19-inch rack, and there's a little switch right here on the side. It's not a continuous turn, it's actually a click setting, and there's 5 settings you can turn on this, and you turn it counterclockwise or to the left to turn the wattage down, and you turn it clockwise or to the right to turn the voltage up. We set it from the factory to be at 10 watts of power. Again, that's based on a dummy load setting. So in the field, you might be able to adjust this slightly to get as close as you can to 10 watts. Beside the transmitter, this is called the GPS synchronizer. And what you need this for, if you only have one HAR station, you do not need a GPS synchronizer. This is only utilized when you have more than one station. So let's say you have 2 or more stations on the same frequency on a corridor. So as you're driving down your corridor, you have multiple stations in line. Well, the broadcast of an AM signal, it's kind of like a circle of diameter. As you drive along, they're going to overlap. So think of 2 circles as they're overlapping. They're going to be something like this as they overlap. You want to have the signals on the same exact frequency. Even though we say 530, it's actually like 530.001 or 0.008. If both of them are on the exact same frequency, 530.001, for example, you won't hear any kind of heterodyning, which is like a helicopter sound or a whoosh sound as you drive through, and it won't sound like any interference. So the GPS actually helps you accomplish that. You put this at each location, and as you drive through and the signals overlap, it sounds like one clean, continuous broadcast. You don't have any kind of interference between the stations. You have to make sure the audio is the same, and we have our Platinum HAR software, which allows you to download the same message to both stations, so they're broadcasting the same message. So it's very nice if you're a Department of Transportation, for example, and you have a corridor that stretches X amount of miles. You can have these stations located every few miles, and as someone drives through, they think they're listening to one continuous broadcast for that whole corridor. And the reason we do this, because FCC limits us to 10 watts of power, these have a limited range. Typically, the range on these is 3 to 5 miles in each direction, which is a radius. So if your circle diameter could be anywhere from 4 to 8 miles of total coverage, you want your signals to overlap a little bit so you can actually have continuous coverage with no static in between where you lose a signal, and not too much overlap where the signals can't be very effective. So you kind of plan your corridor length. You put the stations in about where they need to be for the overlap, and then you put in the GPS synchronizer, and it does all the work. It locates the satellites here. There'll be green lights. You have an antenna for it, and then you turn it on and let it go. It works very well, and they work in conjunction with the transmitter. When we build these, we build this to the frequency of the transmitter. So if this is 1610, we build the GPS to be on the same frequency. Moving over here to the burn-in rack, I want to show you the two quick examples. And again, this is rough because we're in the lab. I don't have my nice cover plates on here, the beauty plates, to make it look really finished off. But you get the idea. This is a 19-inch rack with a DR1500 in it, transmitter, GPS, and a power supply. This is a 19-inch rack with a power supply, a cam 1, and a transmitter, and an optional weather radio. This is a NOAA weather radio. What it does is actually picks up the NOAA broadcast and it just rebroadcasts over the air. So if you wanted to have that intermingled with your messages over the air, you could actually broadcast NOAA weather radio by putting this module in. If you already have it, great. If you don't, you could add that as an upgrade. So from left to right, you'll see I've got my network cable here plugged in from my network, and it's showing an IP address right here. So to access this device, I go into my computer, I type in that IP address, and it'll pull up this particular unit. Now what's cool is this is actually going to pull up a web-based interface that did not exist with this recorder player. This recorder player, the DR1500, you'll see it's actually, I put a message on it, it's broadcasting, it's actually modulating. You can see this here. Because I have a dummy load antenna on this, and when I say dummy load antenna, this is what that looks like. It's just a 50 ohm load that actually simulates an antenna in the field. It shows my tuning VSWR here is off the scale, which means it's under 1.1, which is a very good tuning ratio. When I slide my forward power down, you'll see because of the tuning, we're actually about 12.4 watts is what this is showing. And my reflected is not showing anything because it's tuned so well, it's so efficient, it's at 12.4 watts and nothing for VSWR. Now if I took this same transmitter and put it outside on a real world antenna and ground system, it would probably be exactly at 10 watts. So just give you an idea, this can change a little bit. If I go out in the field and it's too high, I can go in here and flip this switch and crank it down some. Okay. Back to the DR1500 recorder player. So you'll notice I have an analog phone line hooked to it, again, RJ11. And to test it in the lab, I have a phone line simulator here. So what I'm gonna do is show you how that works. I'll take my telephone here. It's gonna answer.
Hello, enter the security code followed by the pound sign. Main menu. To hear the command list, enter *0#.
Now this is how every recorder player has worked since the 90s until just a few years ago when we switched to the Cam 1. So from this point, we want to monitor the broadcast so you can actually see what I have recorded on here.
80%. Sounds great.
Okay, so now you hear my message.
Testing message 3. Over
And here's the modulation.
Message 3, message 3. Testing 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. End of the test. Testing 1, 2, 3. 1, 2, 3, 4, 5. Testing 1, 2, 3, 4, 5. Testing 1, 2, 3.
Main menu. To hear the command list, enter *0#.
Okay, and we'll disconnect. So the way this worked over the years, it was called analog. You'd enter a series of DTMF tones and you could control how the system would respond. So you could tell it to record, to broadcast, to monitor a message, to schedule a message, and it was all through a series of DTMF tones through an analog phone line system. That's how all the older 1500 recorder players worked. By comparison, nowadays you can go here and you can type in your web address, 192.168.50.157, and this is what happens. The Cam 1 has its built-in web interface that comes up like this. This is what you'll see as a customer. And you can go here and simply click login. And because I've already entered my password, it immediately pops up for me because I've saved it, but it gives you a login page with a username and password that you enter, and then it comes up to this. And this is your web interface page. So it gives you tabs to control, to set up, to broadcast, to stream, and this actually tells you the name of it. This is called my MH Corbin Sales Demo is the location. You can put in your location, such as if this is like an exit ramp or a certain street or name. It also shows you the serial number for this particular unit. And then we can go into setup. And again, this is password protect as well. Because I've saved it on my computer, it automatically goes in. And this is where you can actually change the name if you wanted to something else. You can go in back to this page, which is the control page. You can go to broadcast. And you'll notice here, we don't have anything playing right now. So this is where you can actually upload your messages. You can go here, you can choose an audio file, and you can pick from anything in your music or audio. Just pick the file, drag it in here, and then allot it a slot number. So you can just say, I want slot 1 to be whatever file I chose, hit submit. It'll put the message into the system, and then you have to create a playlist for it to play. So you just say, I want to be playlist number 1, and the message number 1, you hit submit, and it automatically will start creating the playlist with that message number in it. And then you just activate it. Say, I want to activate that playlist. If you want to put any spacing or anything in it, you can do that here. If not, you just hit submit. That playlist automatically starts running immediately on it. Let's say, for example, you just want to turn on the transmitter and you just want to run the weather radio. You can go here and click weather radio and hit submit, and the unit will automatically turn on weather radio. And up here in the top, it tells you that the source is weather radio, the transmitter's turned on. So it's just a quick walkthrough of what the Cam 1 can do. It's very quick, very easy, no analog control necessary. You can upload any files that you like, MP3, MP4 type of files, WAV files are very common, and you just drag them in and go. So it makes it very convenient, and the audio quality is so much better with the Cam 1 than it was with the DR1500 and the analog technology. You can reach us at 1-800-380-1718 for technical support. Anytime, we'll be happy to help. And check out our other YouTube videos for any helpful information you might need on all of our products. I'll try to put up more videos like this that should be helpful if you have any questions. Thank you.